Hello, friends. So, for the last five or four videos, we were discussing how to plot the graph of this particular function. And in the process, we actually investigated a lot. We found the first derivative, the second derivative, critical points. We plotted them on the number line, found the maxima, minima, inflection points. We also found the interval of increase, decrease, and interval of convexity. Now it's time, of course, to finally draw the picture. So let's start drawing the picture with all this information in our hand. We first start with the number line. We have 0 and then we have negative 2 pi. We have positive 2 pi. And now what we will do is we will plot all the points, the maxima, minima, inflection points, everything that we have found up to now in this graph. So we start with negative pi by 2, positive pi by 2. These are the points where these are the inflection points. Then we also have the 3 pi by 2. We have the negative 3 pi by 2. We have 5 pi by 4. Actually, negative 5 pi by 4, sorry. Negative 5 pi by 4, negative pi by 4, 7 pi by 2, 7 pi by 4, and 3 pi by 4. Obviously, these are approximate drawings. Now, let's do one thing. Let's compute some of the function values, some of the easy function values at 2 pi, 0, and negative 2 pi. So, we know the function f of x is e to the x sine x. So it is easy to see that at x equals to 0, 2 pi and negative 2 pi, if you plug in the value here, you will get f of 0 equals 0, f of 2 pi equals 0, f of negative 2 pi equals 0. So all these 3 points, the function is 0. Alright, now the question is, what is the function doing between negative 2 pi to 5 pi by 4 in this interval? What is it doing? So if we look into the interval of increase, we will see that between negative 2 pi and negative 5 pi by 4, the function is increasing. So clearly the function is increasing. And then after increasing for up to negative 5 pi by 4, we will have a maxima there. So we have a maxima here, and the function is increasing like this. Now there is a little subtlety here. From up to negative 3 pi by 2, that is up to here, the function is convex. If you see, up to negative 3 pi by 2, the function is convex. So that is below tangent. I'm sorry, above tangent. So it's probably something like this. And from negative 3 pi by 2 up to negative pi by 2, it's below tangent, that's concave. So I'll draw it like this. So see, there is a clear distinction. If we zoom into this region, you will see that there is a distinction, and it actually looks kind of like an S. So it looks somewhat like this. That's the point. Okay. All right. Now let's see what's happening after negative 5 pi by 4. So from negative 5 pi by 4, from negative 5 pi by 4 to negative pi by 4, again the function is decreasing. So the function is decreasing, and if you note that at negative pi by 4, the value of the function is negative. It's a minima and it's a negative. So it's below the x-axis. So somewhere between it cuts through the x-axis, which we need not find. Somewhat like this. So we have a sort of an approximation going on here. It's probably like this, and it's negative, of course. At negative pi by 2, the function's value is also negative. That's why I sort of drew it like this. So it comes below the x-axis before negative pi by 2. Alright, now let's draw it a little bit more carefully. Up to negative pi by 2, the function is concave. That is between negative 3 pi by 2 to negative pi by 2, the function is concave. This is what we recorded earlier. So it's decreasing, it's concave. So let's draw it a little bit more carefully. It's somewhat like this. Now, from negative pi by 2 onward, however, its convexity changes and it becomes convex. So it becomes like this. Okay. And of course, f of 0 is 0. We know that. So it increases from negative pi by 4. How do we know it increases? Of course, from negative pi by 4 to 3 pi by 4, it increases. That's what we have found, interval of increase, one of the intervals of increase. And at 3 pi by 4, we have again a maxima. We have a maxima at 3 pi by 4, which is positive, right? The value, y value is positive. So it's somewhere here. But in between, obviously the function is convex from negative pi by 2 to negative positive pi by 2. So the function is convex up to that. So let's draw it a little bit more carefully. It's convex. So maybe it's a little like this. Actually, if we can change the 0 point, it will be easier. Let me change the 0 point. So up to here, the function is like this. Okay. Now, at pi by 2, the convexity changes. So it becomes somewhat like this. And again, at negative 3 pi by 2, the convexity changes. And it becomes convex here. And at 7 pi by 4, we have a minima. At 7 pi by 4, we have a minima. And not only that, it's a negative value and quite a big negative value. So we will come down like this, and we have a minima here. We have a minima here. Okay, and it comes back, shots up to 2 pi, 0 at 2 pi. So sort of like this. Now, if you look into this particular chart, we used all these information that we found. We found the maxima, minima, inflection points, everything. And we incorporated to draw this graph. And obviously, this picture is just an approximation of the actual graph. If you look at the actual graph, it looks a little bit different. You can draw it using softwares like GeoGebra or something like that. But this particular picture incorporates everything that we have computed, and it's a fairly good approximation of our of this function fx equals to e to the power x times sine x. Thank you, friends, and I'll see you later in a different video. Thank you for watching.